Welcome to i9 Global. Join us as we delve into the basic foundations of artificial intelligence. Let's take a closer look at AI algorithms today. An AI algorithm is a set of step-by-step instructions that a computer follows to solve a problem or perform a task by learning from data, rather than being explicitly programmed. This innovative approach allows machines to analyze vast quantities of information, identify patterns, and make decisions with remarkable speed and accuracy. By leveraging the power of data, AI algorithms can adapt and improve over time, enhancing their performance as they encounter new scenarios. At the core of AI algorithms lies the concept of machine learning, which enables systems to learn from experience. This process involves training models on large datasets, where the algorithms adjust their parameters to minimize errors and optimize outcomes. For instance, in supervised learning, algorithms are provided with labeled data, allowing them to learn the relationship between input variables and desired outputs. Conversely, unsupervised learning allows algorithms to explore and identify hidden structures within unlabeled data, revealing insights that may not be immediately apparent. Versatility of AI algorithms. The versatility of AI algorithms extends across various domains, from natural language processing to computer vision. In healthcare, for example, AI algorithms can analyze medical images to assist in diagnosing conditions with unprecedented precision. In finance, they can detect fraudulent transactions by recognizing anomalies in spending patterns. The applications are virtually limitless, as organizations harness the potential of AI to drive innovation and efficiency. Moreover, reinforcement learning represents another fascinating aspect of AI algorithms, where agents learn to make decisions through trial and error in dynamic environments. This approach has been successfully applied in robotics, game development, and autonomous vehicles, showcasing the algorithm's ability to navigate complex tasks and adapt to changing circumstances. As AI technology continues to evolve, ethical considerations surrounding the use of these algorithms become increasingly important. Ensuring transparency, accountability, and fairness in AI systems is crucial to gaining public trust and fostering responsible innovation. Organizations must prioritize the development of algorithms that not only deliver accurate results, but also adhere to ethical standards. AI algorithms as transformative tools. AI algorithms are transformative tools that empower computers to learn from data, solve complex problems, and perform tasks that were once thought to be the exclusive domain of human intelligence. As we move forward, the continued refinement of these algorithms will unlock new possibilities, driving advancements across industries, and shaping the future of technology. The journey of AI is just beginning, and its potential is limited only by our imagination. How AI algorithms work. This flow indeed captures the essence of machine learning and artificial intelligence. 1. Input data. This is the essential raw material. The quality and relevance of this data are critical for the algorithm's performance. 2. Processing. This is where the intelligence begins. The algorithm applies statistical, mathematical, or logical operations to find structure, correlations, or trends within the data. This often involves transforming the data into a format that the model can understand. 3. Learning. This is the core of AI. Through various techniques like supervised learning, unsupervised learning, or reinforcement learning, the algorithm iteratively adjusts its internal weights, biases, or rules based on feedback. For example, comparing its output to known correct answers, to minimize errors and improve its ability to perform its task. 4. Output. The final result of the algorithm's analysis and learning. This can manifest in various forms depending on the AI's purpose, from a simple yes/no answer to a complex generation of text or images. Types of AI algorithms. At the core of AI are various algorithms that allow systems to learn from data, adapt to new inputs, and make decisions. Understanding the different types of AI algorithms is crucial for anyone looking to harness the power of AI in their projects. Supervised learning algorithms. Supervised learning is one of the most prevalent types of AI algorithm. In this approach, models are trained on labeled datasets, where the input data is paired with the correct output. Common algorithms in this category include linear regression, logistic regression, support vector machines, and decision trees. These algorithms excel in applications such as image recognition and fraud detection, where the model learns to predict outcomes based on historical data. Unsupervised learning algorithms. Unlike supervised learning, unsupervised learning algorithms operate on unlabeled data. These algorithms identify patterns and structures within the data without prior guidance. Clustering techniques, such as k-means and hierarchical clustering, as well as dimensionality reduction methods like principal component analysis, PCA, are key examples. Unsupervised learning is particularly useful in market segmentation and anomaly detection, where discovering hidden patterns can lead to valuable insights. Reinforcement learning algorithms. Reinforcement learning is a unique paradigm where agents learn to make decisions by interacting with their environment. Through trial and error, they receive feedback in the form of rewards or penalties, which guides their learning process. This approach is widely used in robotics, gaming, and autonomous systems. Notable algorithms include Q-learning and deep reinforcement learning, which have achieved remarkable success in complex environments. Deep learning algorithms. A subset of machine learning, deep learning algorithms utilize neural networks with multiple layers to model complex patterns in large datasets. These algorithms have revolutionized fields such as natural language processing and computer vision. Convolutional neural networks, CNNs, and recurrent neural networks, RNNs, are prominent examples that have enabled advancements in speech recognition and image classification. Evolutionary algorithms. Inspired by the process of natural selection, evolutionary algorithms are optimization techniques that evolve solutions over time. These algorithms use mechanisms such as mutation, crossover, and selection to improve their performance iteratively. They are particularly effective in solving complex optimization problems, such as scheduling and resource allocation. Why AI algorithms matter. AI algorithms are crucial because they facilitate machine learning, allowing systems to adapt and enhance their performance over time. By substituting traditional hand-coded rules with data-driven decision-making processes, these algorithms enable more efficient and accurate outcomes. They are the backbone of numerous AI applications that we utilize regularly, including voice assistants, recommendation systems, and smart cameras. That brings us to the end of this video. In our next video, we'll dive into computer vision. Don't forget to like, subscribe, and share. If you have any questions or suggestions, feel free to leave them in the comment section. Thank you.